But today, guys, what we're going to chat about is we're going to recap some number pattern stuff, mostly because, like I said in our first lesson, so those of you that were here on Monday, I said to you that number patterns and functions go or are very, very closely related to each other. They go hand in hand. We get functions by looking at number patterns. We essentially, when we draw a function or when we draw a graph, are drawing a relationship that a pattern represents. So they are very closely related, and I want to just recap this stuff so that we can see if we can identify a pattern, hopefully that then can translate into a graph. So we are eventually going to draw graphs. That's sort of the focus of our next lesson, but it is very important to understand number patterns. So those of you who are new, this will all be in the number patterns videos on Watobe's website, and Yolanda explained how to get there, so you can go and watch those videos if you'd like. All right, like I say, we're going to recap some number pattern stuff. Yes, we've done this, but like I said, this stuff is going to be so important when we start drawing graphs on Monday. So we need to understand it. So the first pattern or first relationship or first rule that we're going to have a look at is this one that I've given you here of y is equal to 3x minus 1. Now, just a very quick reminder, you've got two variables here. You've got y and you've got x. Y, remember, is your output, and x is your input. Whoopsie daisies. Essentially what it is, and we're going to draw a flow diagram in the first question, but essentially what it is you are taking a value, your input, you are applying some rule to it, and you're getting an answer. That's your output. So in this specific rule, we are told that we need to take x, we need to multiply it by 3. That's what the 3 in front of the x is telling us. Remember, that's a coefficient. And then we need to subtract 1. So if we want to represent this now in a flow diagram, that's quite easy once we've broken down our formula or our equation. We know we've got our input. We know we need to take our input and then perform some sort of operations on this input, and we are eventually going to get our output. So the first thing that we do to our input, remember, as I said, is we multiply it by 3. So we find a product with the input and 3. The next thing that we do according to our rule is we subtract 1. And once we've done all of that, we're going to get our output. Now, what this means is you can apply this to any input that you are given. And we're about to do that in the table in the next question. So now that we know what the rule is, and for some people, having a flow diagram is a little bit easier to then apply the rule. But once we know what the rule is telling us to do, once we know what rule to apply, we're able to essentially work out any output we want. But we're also able to take an output and work backwards to what the input would have been. All right, but we'll chat about all of that sort of stuff in a second or two. So let's have a look at the second question, where it now asks us to complete the table. It says using the rule given. So you can either use the rule or you can use the flow diagram. It's really up to you. I'm going to do an example with the flow diagram, and I'm going to do some examples of the rule, just that you can see that regardless of whether you use a flow diagram or like an equation or a rule, you will get the answer. So if we have a look at our first output over here, our first input, we've got -2. So if we take that input and we apply it to our flow diagram, what we want to do is say -2 times 3 minus 1, and we want to get some output of y. So if we say -2 times +3, we get a -6. And then if I say -6 or -6 minus another 1, I end up with an output of -7. So using my flow diagram, I've been able to figure out what my output is going to be. And you can do this for any of your inputs. If we now have a look, say, for example, at the input of -1, we've got -1 times 3, which gives us -3. Maybe I should write this down a bit better. Let me go here. So we've got -1 times 3 minus 1, and we should get our output. So -1 times +3 is -3. -3 minus 1 gives us an output of -4. So using our rule in flow diagram form, we are getting our outputs. Now, you don't have to use a flow diagram. It doesn't work for everyone. Sometimes you aren't given a flow diagram, so it's important to be able to do this without a flow diagram and just using our rule. So remember, our rule here was y is equal to 3x minus 1. That was the algebraic, I don't know what's happening, rule that I gave you in this question. So now if we want to go and use the rule to work out an output, again, we need to take our input, but now we're going to substitute in whatever our input is in place of x. Because remember, the input is our x value. So if we look at 0, we will have y is equal to 3 times 0 minus 1. We know that 3 times 0 is 0. So we've got 0 minus 1. And so we get our output is -1 or -1. So using the rule, we're still able to find an output. If we do the same thing for our next output of +1. Okay, so we're going to substitute into our equation. Y is equal to 3x minus 1. So we substitute in an input value of 1, so 3 times 1 minus 1. We then get y is equal to 3 minus 1, because 3 times 1 is 3. And so we get an output value of +2. And so we can put down our output value for the corresponding input that we were working with. Right, so what I'd like you guys to try for me is working out the output values for the 2 remaining input values. So my 2 remaining input values are 2 and 3. I would like you to find their output values. What I'm going to do so that you can put your answers on the chat, I'm going to call this value over here A and this value over here B. So in the chat, I want an answer for the output value represented by A and the output value represented by B. Remember, you can use your flow diagram or the substitution method. It really doesn't matter, whatever you're more comfortable with. But I would like those output values. And remember, I said at the start, we use the chat to put our answers and to put our questions, nothing else. So I'm going to wait to see some answers before we have a look and see how this is done. Just remember the order in which you need to do your operations here. We've written out both the rule and you've been given the flow, or we've written out the flow diagram and you were given the rule. So make sure you apply it.
Let's go, my people. Let's go.
Also grade 8, remember, if you have a question, it's not, ma'am, please say it again, ma'am, I don't understand, ma'am, I don't get it. It's a specific question. I can't repeat an entire lesson, nor can I reteach an entire lesson. So specific questions so that we can help you. All right, would anyone like to raise their hands to explain how they got either one of those, A or B? Sorry, go on. Tandawake, which one would you like to explain?
Ma'am, I would like to explain also for A, ma'am.
Okay, cool. So we're going to start with A, guys.
Okay, so I just said, ma'am, also, just 2 times 3. It gave me 6.
Good.
and then what I just did, I just said 6 minus 1 gave me 5.
Excellent, well done. Okay, so guys, exactly, we follow the rule and we get our output value of 5. Well done. Anatle, would you like to give us B?
Hi, ma'am.
Hi.
Ma'am, what I did is that I said 3 times 3, and I got 9.
Good.
And then I said 9 minus 1, and I got 8.
Perfect. So B is equal to 8. Excellent, well done. Alrighty. So guys, just a reminder, when we no, see, now my words have disappeared from me. Right, so your answer for A should have been 5 and your answer for B should have been 8. Whether you use the flow diagram, whether you use substitution to your rule, or whether you just did what both Anatli and Tandawake did in just applying the rule and saying times 3 minus 1, you should get the answer. All right, so please, my words today are really not functioning very well. Okay, please just remember that the rule is 3 times x. So on the chat there, we can't say 3 minus 3 because it's not a subtraction, it is a multiplication. So it's 3 times 3. Okay, that's very important. Alrighty, guys, so we can use, or we can be given a rule and we can be able to hopefully find input and output values. Now, hopefully what you are seeing from this, and if you were with us in the first lesson for this new section, you are hopefully seeing that we are getting X and Y values. That's an input and an output, right? And we spoke on Monday about the fact that if we ever want to plot a graph, we need to have coordinates. And we know that coordinates are an ordered pair of X and Y values. And so what you're going to see in Monday's lesson is we are now going to be able to take a rule, get our input or output values, and we are able to then take those X and Y values and plot them in order to draw a graph that represents our relationship. Okay, so now that we know all of this, we're going to be able to actually draw what this relationship looks like. Another thing I just want to remind you is if we actually go and have a look at this pattern and see what the pattern is, we can very clearly see, hopefully, that each time I'm adding 3. So -7 plus 3 is -4. -4 plus 3 is -1. -1 plus 3 is 2. 2 plus 3 is 5. And remember, that all comes from, or if we relate that back to our rule, this number in front of X is whatever we add or subtract each time. So that's why our rule was 3x minus 1, because we were adding 3 each time in this pattern. And again, the reason I'm pointing this out is that you can see that we are constantly adding the same value, or we have a constant difference. Okay, because when we start to draw this graph is going to look quite specific because we're adding the same thing each time. Righty, so I'm just going to stop there in case anyone wants to take a screenshot of this. I'm also going to ask if anyone has any questions relating to what we've just done. You can raise your hand now and ask, otherwise take your screenshots and we're going to have a look at another one. Watale? Excuse me.
Ma'am, can you hear me?
Yes.
So, ma'am, I wanted to ask, ma'am, because this thing was a little confusing, ma'am. At first, ma'am, I said that, ma'am, I thought, ma'am, you're going to multiply the -1, ma'am. Is it possible, ma'am, if we could, like, get the multiply -1, or it stays -1?
So in this specific example, it's -1. But we can have examples where we have a -1 in front of the X. So it could be -x plus 2 or something. And then we are timesing by -1.
Oh, thank you, ma'am.
Okay, so it depends where the -1 is. Itumeleng? Itumeleng, you there? Oh no. All right, pop your question in the chat, Nelson. Am I doing something wrong, Nelson? There we
Yes,
go.
ma'am.
Yeah, no, you were not.
Sorry, ma'am.
Mm.
So, ma'am, when we get the 3, can the rule only be based on the 3x without the
When you
-1?
So it could be based on that, yes, but then our output values will look a little bit different. But I could just have a rule of y equals 3x or y equals 2x with no minus or plus anything.
Okay, ma'am.
Okay, good. Oh, now you're also making me think of fun examples to do for our graphs. Good, Nelson. All right, guys, so I'm hoping we've all got screenshots. We're going to have a look at another example now. So this is now, I want to say it's Batala's question, and clearly my brain's not working too well today, but I'm fairly certain it was. This is now the question of, do we only subtract 1? Can we not times by a -1? And if we have a look at our rule here, that's exactly what we're doing. What we need to remember is that in front of any variable, x, a, b, z, whatever, in front of any letter, there is an imaginary 1. And so here, there is actually a coefficient of -1 to this x. Now, what that means is when we draw the flow diagram, we need to remember that this first term over here, this -1x, is telling us to take -1 and multiply it by x. That is the relationship between a coefficient and its variable. It is times. So when we draw our flow diagram, our input value needs to be multiplied by -1. And if you want to put that -1 in brackets, you're welcome to. Just remind yourself that it is negative. We then, as you can see from our rule, need to add 3 to that product. And we will then get our output value. So very importantly, when you see a negative in front of a variable, it is a coefficient of -1. And so what that means is that we need to times by a -1 before we then add or subtract whatever we're potentially dealing with. All right, so what I want from you guys, and let's just put some letters in, oopsie daisies. I want the output values A, B, C, D, E, and F according to this rule. So I want you to try this table by yourselves. There's 6, so your answers A, B, C, D, E, F. Try and do all of them first and then put all the answers on the chat just so that I'm not getting like A, B, D, F, blah, blah, blah. Try to do them all and then just put all of the answers at the same time on the chat. It just makes checking a little bit easier. There was a question on the chat of, do we follow BODMAS? So, Tumeling, we essentially do the algebraic rule, whatever it may be, will make us follow BODMAS. So because I've got -x plus 3, I have to do the multiplication first and then the addition. So whenever we've got an algebraic rule, so like an equation, it automatically follows BODMAS. So yes, in very short answer to your question. Okay, so guys, just remember, especially for the first two, that -2 and -1, they are negative. So just think about what happens when you multiply a negative by a negative. Okay, we need to be careful of our sign. Sorry, apparently I just turned off my video. Clearly today is a day.
We can still see you. Just to clarify, guys, while you're still busy, For those of you who are saying network issues, logging in and all of that, it could be sometimes that it's not even network issues because you are sitting at the waiting room since you are late. So you might be sitting at the waiting room for like 5 minutes or so because you are late. Then you need to read my instructions first before you can enter into this class, okay? So please make sure that you are not late in class.
Yeah, guys, I want to echo that as well. Like, sometimes we have people trying to join 5 minutes before the end of the lesson. You can't learn anything in those last 5 minutes. We don't do anything. We do polls and we chat about quizzes and stuff. So make sure that you join on time. Otherwise, unfortunately, you're just losing out on the lesson. Vishali, well done. That's how I want to see those answers. I'm hoping I'm saying your name correctly. You must correct me. Guys, if I ever pronounce your name incorrectly, please correct me. Like I do try my best, but no one's perfect. So do correct me. Glad I'm starting to see some answers. Well done. Keep them coming.
We can do this, my people. Let's go.
Well done, guys, and well done on listening to the instruction about how to give your answers. I appreciate that. Well,
Yeah, I think they've learned a lot. We are
Hmm.
growing in this class. Even my son is like, well done, my people, at the back.
Oh,
So you are
love
getting the
making.
cheer for me and for my son, guys.
Never even met the kid, and I just feel like I get him, and he gets me. Watale's got some fancy ABCs and Ds and all the rest of it there. Very fancy.
guys.
Sorry, guys, my cat was crying and I didn't really understand why, so I just had to find out, but being drama queen, apparently. Right, guys, well done. I'm going to give you 1 more minute because I haven't seen a lot of full answers come through yet. So 1 more minute, and then I'm going to ask for some answers. Please remember, questions on the chat. I shouldn't see any hands yet. Okay, if you'd like to raise your hand to explain one of them for us, please do. And remember, guys, I try and give everyone a chance. So if I picked you, I might not pick you again because we need to try and give everyone a chance to give us answers. Loving how many hands we have going on here. Excellent. I hope I say your name correctly. Prasanna?
You did kind of say it right.
Okay, say it for me so I can say it properly.
Prasanna.
Prasanna, thank you. Okay. Tell, which
Okay,
one are
so
we
what
doing? A.
Yeah, A. So what I did was -2 times -1, which would make the 2 a positive, which would say +3 plus +2, which would equal to 5.
Okay, good. Sorry, I lost you for a second, but I'm now there. Right, so guys, very importantly, a negative times a negative is a positive, and I said this. So negative
I
2
have
times...
a question.
Yes.
That's okay. So for F, I got 6, and I'm not really sure how I got 6.
Okay, so when we get to F, we get double check your work, and then if you're still a little bit confused, when I ask for questions, raise your hand.
Okay, thank you.
Okay, right, so guys, -1 times -2, +2, and then +2 plus 3 is 5. So A here is 5. Very nicely done. Let's have a look then at our next one. Whoopsie daisies. Tapelo? And guys, just a reminder, if you don't unmute yourself,
miss.
do you want to answer?
Yes, miss.
Okay, B.
Yes, miss. -1 times -1, miss, would make the 1 positive, and it would be +1, miss. And then +1 plus 3, miss, would be 4, miss. +4.
Excellent, excellent, well done. So once again, guys, we're getting a positive answer here because exactly as Tapelo explained, negative times a negative is a positive. Okay, just a reminder, sorry, before we carry on. If I call your name and you don't unmute yourself in those 5 seconds, I move on to the next person. Otherwise, we're just waiting for nothing. Bali?
Hi, ma'am.
Hi.
So what I did for number C is that firstly I used the format, the rule. Then I later on went on, then I put the 0 first, the bracket -1 plus 3. Then while I calculated that, it gave me an answer of 3, ma'am.
Perfect. Right, so guys, I like there. We can use a rule as well. Remember, I said that to you. So our rule was y equals -1 times x plus 3. -1 times 0 is 0, so 0 plus 3 is 3. So C should be 3. Very nice. Whoopsie daisies. Princess, do you want to do D for us?
Yes, ma'am.
Okay, I'm ready.
So for D, you're gonna say 1 times -1.
Good.
And then you're gonna add 3. We're gonna add 3, which will give us 2 because
Per-
-1 plus a positive.
Perfect. Okay. Sorry, y'all keep going.
Yeah, ma'am, my answer is 2.
Okay, perfect. So guys,
Thank you.
exactly. And I think that's what Princess was trying to say, and I just kept talking. 1 times -1 is negative. Okay, so negative times negative, positive. And then exactly if we've got a -1 and we're adding 3, we're going to end up with a positive 2. So D is positive 2. Well done, Princess.
Thank you.
Lexa, do you want to do E for us?
Hi, ma'am.
Hi.
So on 2, ma'am, I basically said, ma'am, 2 times -1, which gave me the answer to a -1, then a -2, ma'am. Then I said, then I added 3, which gave me 1.
Perfect. Well done. So guys, again, positive times a negative is a negative. So we get -2, and then we add our 3, and that is how we get our answer of 1. Bootle, do you want to do F for us? Okay. Retu?
Yeah.
Retu, is that you? You there?
Yes, I'm here.
Okay, are you going to do F for us?
Yep.
Okay.
3 times -1 plus 3 is equals to 0.
Perfect. So F is 0. So 3 times -1 is -3. And -3 plus 3 gives us 0. So exactly F is equal to 0. Well done. Right,
Thank
very
you.
nicely done, guys. Remember, try and give everyone a chance. So those of you with your hands up, thank you for being willing to share. We are going to do more examples, so hopefully you'll get another chance. But well done. I'm just leaving this here for you to screenshot. I saw there was a question of, can I scroll down? You can see everything, so I hope that's fine. So guys, please take your screenshots. While you're doing that, if anyone has any questions, now's the time to raise your hand. Otherwise, we are gonna, I think, maybe have a bit of a brain break. Bontle?
Hi, ma'am.
Hi.
Ma'am, I would like to ask, whenever we're doing the flow diagram, for the X, should it always be in brackets? Or if we don't put it in brackets, is the answer still gonna be right?
So when you say in brackets, do you mean this part of the flow diagram, whatever I'm timesing it by?
Yes, ma'am.
You don't have to put it into brackets. I generally put in, if I'm timesing something by a negative, I generally use brackets. It's more to just remind me that I am timesing by negative. You won't get it wrong though. Just remember that you are multiplying by a negative. So you have to then take your X and times it by a negative whatever, in this case 1.
Okay, thank you, ma'am.
Sure. Sake? Sake, you there? There we go.
Yes. I'm gonna please ask, -1 means subtract.
So in this case, it's meaning multiplying. So if we go just to our rule up here, I'm just going to write it a bit bigger over here. So the rule was y equals -x plus 3. So if we break down that term over there, remember there is a 1 in front of that x. And because there's no sign in between the -1 and x, this is telling me to take -1 and multiply it by x. So in this case, we are multiplying by a -1. Once we have that, then we can subtract or add or whatever. But in this case, this -1 is being multiplied with the x. And that's because it is a coefficient to the x. So anytime we have a coefficient, we are multiplying. Yes, okay, I hope that makes sense. Guys, I hope you all got your screenshots. Brain break. Definitely well deserved. Math stroke of the day. Right, so guys, remember our brain break. What we want is we want the final, whoopsie daisies, the final answer of this last equation. So you need to work out what each of those things values are. So the karate jacket, the ice skates, and the chess pieces, you need to figure out what each value is so that you can tell me what the final answer is. And remember on the chat, we just want final answers so that we can see who's the first person to get it right. I'll just need to do it as well, otherwise I'm not going to know what the answer is.
Guys, I'm here for the joke. I'm like legitimately just taking a screenshot. I don't know how many of you looked at the joke, but it is quite funny. I love the way that these jokes are so lame, but lame in a funny way. I love them.
I've started at school, so I do I've got like a funny ball. I call it the funny corner. And so I put like math jokes up and like little punny things. And my grade 11s got so excited about it. They asked me to bring in like a whiteboard for them so they could come up with their own jokes. And so now every day they come up with their own jokes. And so we're doing trig at the moment. So they've come up with so many good trig jokes. But I'm quite proud
That's
of
so
it.
cool.
Yeah.
So to all our newbies, welcome, Kuliso. I see you. Kuliso, so basically, and the rest of you guys, basically now the brain break, right? You don't even have to stress about. So brain break is just something that you need to stretch yourself because 1 hour is long, okay, to be focusing. So you need to just stretch, make sure you feel fine. And then when you get time, you can solve the question on the board. But this one is not the topic that we are doing. It's just something that is gonna help you when we do algebra. Okay, when we do some equations, when we do something, it can really help you. So give it a try. And normally we do explain how we did arrive to the answer so that you actually keep up and you will know what's going on. Okay, my newbies, if we see the correct answer, we will definitely let you know. Kamo, I see your hand is up, but we will definitely give you time to raise your hand. At this moment, you're putting your answers on the chat. If we see that is the correct answer, I'll definitely call up your name. So far, no right answer.
We're getting
36
there,
is
guys.
wrong, my people. 36 is really wrong. Tenor, same applies to you. You cannot raise your hand. Just give me some answers on the chat.
And guys, remember, if you have questions, use the chat. That's what it's there for. We can see the chat. So ask your questions there on the chat for us.
No,
And
it's
remember
not
BOD
104. Yeah, it's not 104. It is not, woo, please. It is not those numbers. None of those are correct. We are looking for the final answer, the final number, the way there's a question mark. That's what we are looking for.
Guys, I've
For my
seen this
people.
twice. I've seen this twice now. 12 times 46 is some ridiculously high number. So the second one can't be 12 times 46. You want 104. 12 times 46 is 552. There's no ways to get 104. So just be careful there. I don't know if it's just a typo or what, but no.
Leonor, I'm seeing this for the second time now. Please don't spam the chat, otherwise I'll remove you.
And guys, no hands yet.
Yep, and if you want to ask about the previous lessons, please feel free to do so, but on the chat, okay?
Grade 8, no hands. No hands. No. Questions, put them on the chat.
Nope, it's not 173. Do you guys want to take this as a homework? Yeah, I'll have about 2 minutes to get it right. Nope, it's not 172. Not even close. Guys, we can do this. Nope. Nope, but the clue is there. What is 36 divided by 3? If you can tell me what 36 divided by 3, it means that that number will be placed in all those 3 boots there. Then once you have that, then you know that, okay, 2 boots, you have an answer for it. Then what is that number multiplied by the chess thingy plus adding this chess thingy that will give you 104. Once you have that, then... Yeah, also disturbed. Who is that? Tingo.
Tingo.
Well done, Tingo. Sorry, Tingo, I got so disturbed. Well done, Tingo. Tingo, you can raise your hand to come and explain to us how did you arrive to the answer. Thank you, Tingo. Nearly this was gonna be for homework, guys. So Tingo has came into your rescue. Tingo, please explain to the class. Let's go.
And so for the first one, I divided 36 by 3, then it equals to 12.
Good.
So then for the second one, I've tried minusing like 104. Then I've came to like a conclusion that for the second one, it is 12 times 8 plus 8.
Good. And guys, just quickly, BODMAS first. So 12 times 8 is 96, and then 96 plus 8 gives us that 104. Excellent, Tango, keep going.
Then after that, I said 4 times 7 equals to 28.
Good.
Then you plus 4 with 28 equals to 32.
Excellent.
So then 7 plus 12 times 4 equals to 55.
Excellent, well done. Guys, again, bod mass. 12 times 4, 48. Oops. 48 plus 7, 55. Well done, Tango. Excellent. Okay, so guys, just to point this out again, yes, this seems like a silly little maths thing, but honestly, when we get to equations, this stuff is going to help you being able to look at an equation and say, okay, I've got 3 of the same thing that I'm adding. How do I solve that? That is how you are going to be able to solve for variables and equations. So this practice now, hopefully, is going to really, really help you when we get to our equation section. Nelson, I saw you said you got it first. I'll be honest, I did not see your 55 on the chat, so I do apologize if you were first, but well done.
Yeah, and well done to you. Sorry about that.
Alrighty, guys. Okay, we can do it. One more. So if we now consider the table, excuse me. So here I'm giving you the table, and we want to figure out what the pattern is, and we're eventually going to get a rule. And I know some of you were struggling with the rules, so it would be really helpful to listen now so that hopefully we get it. If we go and have a look at the values in our table, I've given you all of the inputs. It's the outputs I need a rule for. So what I need to ask myself is, how am I getting from an output of 2 to an output of 0? Well, I subtracted 2. How do I get from 0 to -2? I subtract 2. And hopefully what we're going to start to see is that this pattern remains the same. So -2 to -4, well, I subtracted another 2. And so luckily what we're seeing is that our pattern is remaining constant and we are subtracting 2. So in A, when we're asked to describe the pattern in words, we can now state that we are subtracting 2 to get from one term to the next. Some of you like to say adding -2. That is absolutely fine. Because remember, if you add a -2, that plus minus situation is actually a -2. So it's the same thing. It really doesn't matter. So now we know what our pattern is. It means that we can carry or continue this pattern on in order to figure out these missing blocks. Okay. So if we now subtract another 2 from -6, I get my next term, which is -8. If I subtract another 2, I get my next term, which is -10. And so essentially, I can just keep carrying on my pattern to continue finding output values. Now, remember, we spoke about this in our pattern section. As great as that is to just keep subtracting 2, if I then went and asked you for like the 35th pattern, you don't want to sit subtracting 2 until the 35th one. You want a quick way to get to your answer. And this is now where the algebraic rule or the equation that we have worked with is going to be very helpful for us. So here it asks us in question B to describe or determine an algebraic equation in terms of x and y. Remember, what we can sometimes call this is the general rule of our number pattern. Okay, so when looking at our general rule, we want to be able to essentially find one rule like we did over here in question A and B. So we want to find a rule like the y equals that will allow us to find any output that we have. So remember I said to you in the first example that the trick or the clue that we need to use is whatever we're adding or subtracting. So we always start with y equals because y is our output. And then what we do is we say, okay, whatever I'm adding or subtracting each time, I multiply that by x. So I've got -2x. I then need to just double check if there's anything I still need to add or subtract. Enough on the chat, grade 8, enough. We have only got a short amount of time, stop. We now need to decide if we need to add or subtract anything in order to actually get the output that I want. So remember, I need to figure out if there's anything else I still need so that my Y values correspond with what is in my table. So for the first, let's call it column over here, where we've got an input of 0 and an output of 2. We know that we want 2. If we take our rule as it currently stands and we say, whoopsie, and we say minus 2 times 0, that gives us an answer of 0. But I don't want an answer of 0. I want an answer of 2. And so what that means is that I still need to add 2 to the 0 in order to get that output that I want. So this tells me that I still need to add an extra term here. We can also double check ourselves. Remember, we spoke about this in patterns. If I go to my next column and I double check my rule, I've got an X or an input of 1 and an output of 0. So when I substitute this in, Y equals negative 2 times 1 plus 2, I need to make sure I get my Y output of 0. So negative 2 times 1 is negative 2, plus 2 does in actual fact give me 0. And because I get the output I want, it means that this rule that I've written down is correct. And so now I could potentially use that rule to find any output value in my pattern. And so this is why rule is so helpful to us, because now if I say to you, give me the 35th term, you don't have to sit and write it out until 35. You can just substitute in and you can tell me what it is. All right, so grade 8, we have done this in the pattern section. Please go and have a look at the videos if you're feeling confused.